think that's the time to start. Welcome to the session, Be Proactive About State in Your Reactive System. I hope you are all relaxed from the break. I'm actually super excited, and my goal after this 50 minutes is that you leave this room super excited about state and workflow engines, and I will be the one that is chilled and relaxed. Let's see if I can achieve that. We talked today about reactive systems, and maybe a disclaimer here right from the beginning. It's not just about reactive programming that we know from Spring. It is more about reactive systems also in sense of a distributed architecture. So let's get started. Who am I? My name is Nele. I work at a company called Camunda, and I'm a developer advocate. And what I'm really passionate about when it comes to coding and software is actually the architecture. I really like it because it has a lot of different patterns. You can find different shapes there, and it's not like black and white. And what I really like about Spring in that term is how easy it is to integrate different components here with Spring and make the architectural component aware of your application. The avocado there is there on purpose, not just because I'm a developer advocate. I'm also a foodie. And today we talk about a system, and I thought we need a system we all can relate to. As a foodie, I encounter myself very often in a system called restaurant, consisting of 3 services. We have maybe the waiter, the chef, and the barkeeper. This is the system we talk about today. And if you see those components, and we talk also about distribution, there might be even coming another term into your mind when thinking of distributed systems, and that's actually microservices. Just a quick question, or a quiz question maybe. What term is older? What do you think? Who thinks microservices is older? The term. Okay, one person. Who thinks reactive systems is older? Okay, there was one person with microservices. You got it right. Microservices was first defined 2011, and there was even some terms before. And it's not really surprising because decoupling or decomposing the systems into smaller parts is nothing new. We did that already with service-oriented architectures. But what is new is actually that we really think of each service also has its own database and an own team. But the idea of having different services within a system, it's not completely new. It's harder for microservices to have a single definition because there are so many out there. So I think you will not find a conclusive list of what a microserver service architecture defines. It's not really about the size of the service, but what really is important is that those services are independent deployable, that we have a loose coupling, and that we are fault tolerant. And those architectures characteristics were defined, of course, because we are facing new requirements when it comes to software. So we have a higher demand nowadays. And reactive systems, it's almost the same time, well, a little bit later, but the manifesto was signed 2014, so I think the term came across 2013 the first time. And in reactive systems, we have this manifesto that was signed by a group of developers, and here the manifesto basically gives us the characteristics that a reactive system should be. It should be overall responsive. That's the first thing that it needs to be. If we are not responsive in a timely manner, we can forget about the rest. If we are responsive, the reactive system also should be elastic. That means it should scale up automatically to the need of the resources. So if we have a high demand, the system should scale up. It should be resilient, and it should be message-driven. And you see already there might be some overlapping here between both definitions, and reactive system, of course, is also used a lot when we talk about reactive coding in a non-distributed way. But today I'm looking what can we apply for microservices from the reactive system, and how can we make a microservice architecture reactive? Okay, cool. There is a tutorial that you can also follow that gives you a good insight on how you can build reactive systems. I'm going to go through some parts of it and just mention it here. And coming back to the most important part, the restaurant system, and I'm really excited about this. So let's see how our restaurant works for today. So we have the customer, and the customer is hungry. That's the first important thing. And then the customer will place an order with the table service. The table service will handle the order, and it will place a drink order for the bar and place a food order for the kitchen. And then at one point, Hopefully we get drinks and we get food. And this is then returned from the bar service. The drinks are returned, the drinks are ready, and the table service can again deliver the drinks to the customer. And at one point also the food is ready and we deliver the food also hopefully to the customer. Now we need to define how we do that. We need to define how can our services communicate. And in architectures before microservices, so before we had the high demand or we had the demand of high throughput, a very common way is the synchronous communication, an imperative call, doing a REST call from the table service to the bar service. That means basically the bar service needs to expose a controller, so it needs to have an endpoint that we can call. And then the table service can use this endpoint. You can see that here. And what we do basically is we use the endpoint, we call it, and then we wait till we get a response. So this might work, but the problem we really have here is that it's a blocking call. So that means I do the request, I wait for the response, and then I return to the table service. And that means I don't have the thread free the whole time. That means the thread is used. I have just a limited amount of threads. And if I talk about high demand, for most architectures, this is not working anymore. And if I look now into the overall system, if I implement everything here with web and REST, and I can do that easily with Spring components. So I have web REST and REST templates I could use here. Also for the database connection, I can use some Spring components, but I will create a system that has a lot of blocking calls and probably is not responsive. So doing this blocking is not a good idea or not a good way if we want to create responsive architectures. I said already, if we are not responsive, we don't need to check for the rest. So let's keep going. A solution that was introduced to not have blocking calls anymore in Java is reactive coding or reactive programming. And the idea here of reactive programming is that we still have an endpoint from the bar, but we are not waiting anymore. So we basically do the request and we return directly. And then at the point where the data becomes available, we will tell the table service, hey, your data is there. And then we can bring the data into buckets to the table service, and the table service can consume it. That means the table service still uses this endpoint, but is not waiting anymore. The big benefit here is we release the thread after we did the request, so we are not blocking anymore. We have an asynchronous communication in place. We can use the thread for different requests, and that means, we probably have the possibility for a higher demand for more requests. We can handle more requests with more threads. Or, well, not more threads, but we have more threads available or sooner available. Cool. We can apply that, of course, to the architecture here we have, so not just the bar service and the table service. Very nice, we get rid of those components, and we add to our POM file different components, and we could say we make them all like reactive. We can use Webflux and a web client. We can use data reactive, MongoDB interaction with our database if we have a MongoDB. So we really ensure that we don't have blocking anymore in the architecture. Now I'm coming to the point where we are not just talking about reactive systems in a non-distributed way, but also in a distributed way. So the problem I have here is that I still expose a lot of endpoints. So I still run the danger to create something I would call, or I call interface spaghetti, where you have a lot of endpoints you need to maintain and you need to take care of, and that can get quite messy. Also, if we think of a distributed system, so let's take that responsive and maybe also elastic if we put it into maybe a Docker and a Kubernetes. But if we talk about distributed systems, that's not really message-driven. This is more like, okay, non-blocking calls. But what I really want in a distributed system is I want to have a message that gets my new API. I need to basically think of how I want to implement my business logic. And if you talk or if you find microservices, a very common way you will find is the Saga pattern. And the Saga pattern actually takes care of the business logic and is responsible for it. So it prevents us from doing distributed transactions and uses local transactions, but also makes sure that the Saga is completed. And if there are things going wrong, also it makes sure that we roll back and things like that. And implementing the Saga pattern just with reactive coding is not possible. So we need actually to think about messaging in a distributed system. And a very common way to do that is actually to introduce a message broker and have loosely coupling with messaging here. And introducing a message broker in this architecture could look like this. So I have the table service, and the table service uses, in this example, Kafka here as a message broker and creates a message which is called drinks order and publish it to the message broker. I have the bar service that then can consume this message. So the table service does not really need to know about the bar service. The only thing they share is the message. They need to know how the payload looks like from the message. And then the bar service has the opportunity to publish something back to the message broker, and the table service can consume it. And yeah, this is like then the listening part of it, using Kafka here as a listener, listening to that message and saying, okay, if I have this message, I do something. Okay, let's exchange that here. So let's exchange the points that we don't want. So we don't want the applications to interact with each other anymore. What we want here is actually introduce messaging, and also very nice that we can use some Spring, some stuff from the Spring framework. We can use, for example, the Kafka thing you saw, but also from RabbitMQ, you have the possibility to use messagings. There is a bunch available. And you could still use the reactive part where it makes sense. So you could still have a reactive connection to the database, because overall, it's quite useful if you have non-blocking services when it comes to the communication with the database. And well, maybe also you have some Webflux still available to connect to the front end. And let's look like how this looks like in real life in the system. So I take you to my IDE, and I have here those 3 services. I have here first the kitchen service, and you can see there is not that much business logic implemented. I just want to show how systems are glued together. So I have here the food order consumer and the food ready producer, and the consumer basically waits for a message that says food ordered, and then once it receives the message, it will print something and then sends the message again that the food is ready. I have something similar for the bar service, and the really interesting part becomes basically the table service. There is going on most parts. And if we look at the table service, we can see that we get here the order received from the customer, and then we split this order into the drink order and into the food order. We are basically just passing around a string here for this demonstration. And then also if the bar and the kitchen are ready again, I have here the waiting message food ready and drinks ready. And then I send again a message to Kafka saying that the drinks are ready here with send drinks. And I'm going to start the services up. Also the bar service, and I don't have a fancy front end. I have my terminal. I like my terminal. So what I have here is I wait here for the message for food delivered. I wait here for the message drinks delivered, and here I can create my new orders, and that should work. I tried that already. I was not brave enough to do it live here without trying two times. So I thought, okay, let's see if everything works. Cool, perfect. So my services are doing the things I expect them to do. That is great. Let's go to the presentation. So you see the system kind of works. I have my messages. They are flying around. I can get my order. This is quite handy. I can tick the boxes. I can say we are responsive now. I can say we are also elastic because we can scale or we can deploy these applications to or we can create Docker images, and then probably if we deploy it to Kubernetes, that would make this whole thing elastic. We are resilient, so if one service fails, the whole system is still in place. It doesn't mean that the system cannot answer anymore, and we really are message-driven in a distributed system. And the tutorial basically here stops. And that was my learning experience, but then I was thinking I still have some problems here, because what happens if I'm not having just 3 services? We are very simplified here, right? What happens if I also have a cache service? So maybe my table service is not taking the cache afterwards. What if this is related to an accounting service, and then also maybe I offer a buffet in the restaurant that needs a buffet service? And maybe I have takeaway as well, and a bunch of other things. You can see how easy we can make a big system out of this. And normally we deal with bigger systems and bigger logic in our companies. So the problem I'm facing here is now I have a lot of messages floating around, and it gets really hard for me to understand when the customer is not receiving the food and now ask me, hey, what's going on with my food? And I'm like, I don't know, because all services seems to be fine. Maybe something went wrong with the payload. I don't know how to look for your message exactly now. So it's not super easy to clean all the messages up, or, well, let's say to detect problems quickly from a business perspective if a customer is not getting the thing they need. Also, the observability is not there, so I have no understanding in this scenario how the system is working. I have no visibility which message is coming first, which message is triggered by that, so I really have a hard time understanding here the logic and the flow of the system. So the observability is not really there, and also that makes it hard to understand what's going on. We can change that by adding state to our created reactive system. And there are multiple ways of doing it, and one way is actually using a component called workflow engines. Who of you has heard about workflow engines? Okay, quite a few. Okay. A workflow engine defines a Saga and can be an orchestrator in a microservice architecture. So instead of going from event-driven, we can go to we orchestrate things. So we can say we start the Saga, the process, and then once we arrive at service A, we do a certain thing. So service A knows it has to perform an action. Then we do service B, then we do service C. And there are multiple workflow engines around that can be used for microservice architectures. For example, Netflix has Conductor as an open source tool. You find Cadence, that's from Uber. It's also open source, and on the proprietary side, there's AWS step functions. So there are multiple tools around that use the idea of defining the Saga in an orchestrated way. And yeah, let's see how we can actually introduce that to our architecture. And I think maybe we had this assumption already in the beginning when I showed the HTTP calls, that we saw that actually the table service contains a lot of logic for us. And also with the HTTP call, what we really had is that was the orchestrator there, right? So we gave in the HTTP call scenario the table service the job of the orchestrator. And from the business point of view or from the logic point of view, it makes completely sense to tell now, okay, I give the table service some state. And I'm not doing this by having a database where I write the state into it, but I'm connecting it to a workflow engine and let the workflow engine handle the state of the table service. And we are still connected to the message broker, so to publish and consume messages. That means that the bar and the kitchen are not really aware of that state that the table service is using. And you can see here what we've described earlier in the flow of the messages in a language called BPMN. And that's a way of defining workflows for the workflow engine ZB I'm going to use later. And I like that a lot because I found it quite handy that we can now talk about what's going on in the system. Makes it very easy, makes it easy for new people joining the team because you have really a quick overview what's going on. And also sometimes we need to talk to different people that are not coding, and this is really nice. Other workflow engines use YAML or text-based approaches. I mean, that also works. I don't want to say that doesn't work, but I really like BPMN. I don't know, I really like it, and it makes it really easy to understand what's going on, and it's a great feature to have. Looking now in the overall architecture, what we do is we keep everything as it is, but we have the workflow engine attached to the table service, and now we have also the ability, at least, I go back, if our customer is not getting drinks, for example, we can see where is the problem in the runtime of our process. So we can see maybe that the message drinks were not delivered, that we have something waiting here, so we know, okay, then maybe it's maybe we have to look at the bar service because the bar service has not produced this message. And then we have a good way of debugging the system and finding the problem if a customer reaches us. And yeah, I think it's time to see how that looks like in code. And I'm here with I'm using here the BPMN tool, and let's just quickly build that. So I have the order received, and I handle the order. And I'm waiting here for 2 messages to arrive. And then we do deliver food and deliver drinks. Perfect. And now what we have to do is we have to bring this to the code. So we have to make our table service aware of this. And yeah, I give this process a good ID. That's like our table service process. I'm normally not so good with names and naming, but okay. And I'm going to save the file, not in pictures. Somewhere Spring.io. And that's a presentation I'm doing, so I'm saving this in my main resource folder. And I'm naming this thing table process. Good thing. So now it should live there. I open the IDE to double check if I selected the right project. I did not. Oh no, I'm in the bar service. I have to, of course, go to the kitchen service, and now I have here my BPMN diagram. I can even say, okay, maybe we put it in a new thing and we call it models, and then I put the process in there. Perfect, good stuff. What I have to do now is, of course, I need to make the communication in the service with the, and behind the BPMN model, if you like text, you can use XML because every graphic has the XML notation, so if you really like text, use that, but I like the model. Okay, cool. So what we need to do now is we need to make aware the table service that the workflow engine exists, and to also deploy the diagram to the workflow engine and things like that. So I'm going to add the dependency here. I'm using ZB as a workflow engine, and yeah, I mean, that's a workflow engine from Camunda, so, but I said there are other options as well. I know this one best, and I also like BPMN, so that's why I'm using this one today. And I'm opening the POM file, and you already see what I have. It's not that much going on here. I have the Kafka stuff, and I have an H2 database. So basically, I'm going to add the ZB stuff here, and hope I have to define a version. And let's do that. Perfect. And now what I can do is, and you see already, or I hope you see that it's very easy to integrate this. What I can do here in the application now, in my Spring Boot application, I can use first the Able ZB client, and then I also can use a deployment here, and a ZB deployment, and I'm basically copying and pasting this because I normally do some errors here in the syntax, so not today. And then I can tell here, with starting the application, hey, please deploy my diagram to the workflow engine ZB. Of course, I need to make some changes into the application YAML so it really connects to ZB, and I'm going to use the cloud version today, so I have somewhere, hopefully here, application properties defined that I'm going to copy and paste. Basically, I'm saying, okay, I get a new file, application.properties, and perfect, and I can get rid of the YAML here. Perfect, so now I am also making sure that I'm connected to ZB. The next things I can define, let's define a package, and let's say this package takes care of the process logic. So I'm saying here that this will be the ZB controller. And then what we want to do, let's have a look here what we actually did already. We made sure that the application now deploys the diagram to the workflow engine. That's already great. But now we need to start this whole thing because we want to actively monitor the state. So if I look here in the order consumer, what I have here is I received the order, and actually that should start triggering the process. So I want here to call the process to say, hey, start an instance of the process, and then I don't want to use the order producer at that point to send drinks or send food. So I want to find a way to start the process. And so in my ZB controller, I'm defining a new class, and I maybe call it just starter. And have here a method called start process. Perfect. And then I can say here basically auto-wire, and then we use the ZB client. And that's the thing I really like about Spring, that you can do that so nicely. And also you see it integrates quite well. So now I have this public void process, and then maybe I should make it a little bit bigger. And then I can use basically the client and say new instance command, and let's see what I get. I have this BPMN process ID. I probably need that one. And also what I can do is latest version, and I can also do some variables. And then I do a send and join. And here what I want to get actually is a string. I want to get the process ID, and maybe I also want to get the order ID that I'm passing around. And then I can put here the process ID, and here the variables. Actually, I have to create a map. Did I use the right wrong? So string object, and I call it variables. Perfect, and then I can say variables put order ID. Perfect. And here I also hand in the variables. Nice. And how do I do that now in the order consumer? So what I do basically here is I say now, or I auto-wire also the how did we call it? Just starter. Okay, that looks good. And then I say starter.start process, and then actually I need to find the process ID, and again this is how we match here with the model. So here we have the ID of the process, so basically I'm going to use this one here and say this or put it here, and then I also can hand in the order ID that I'm getting from the Kafka topic, and I start the process perfectly. So next things we need to do, we started the process is we want to arrive at the point where we handle the order. So we give here the component to a worker. So we are not doing it directly anymore from consuming the message. Now we say to the workflow engine, hey, make this work available once you have a process instance. So we create a service task, and this is how we map it in code. So we say this has a type similar to the topic in Kafka, how they find each other. So I say this is handle order, and I can go into the ZB controller and define a new worker class. Oh yeah, first class. Perfect. And component, and then I do the annotation here for the ZB worker. So here we know basically the type that I just described, and we will tell it to autocomplete. And then we need a method. Perfect. And what I can do here now is just having the ZB worker, but also auto-writing now the producer actually, because in that logic I want to create the message for the Kafka or for the kitchen and for the bar, so that they know they have the message. So I'm going to use the order producer. And perfect, what I can do then is order producer send food order, and I also say order producer send drink order. Cool, and I need to get the variables here, so let's do that. So let's take the activated job here from the ZB engine and get some variables. Get variables as map. So we have a final map. And object process variables typo. Perfect. But now I can basically say string order ID, and then I say process variables, and then we have the get order ID. Perfect, and then I can hand in this, and I need to cast this. Perfect. Okay, cool. Let's give it a try. I mean, we are not done here completely, but let's see how that looks like so far. So we have here the handle order that should work. We have here the process that should start, and then we need to take care of these messages actually, but let's just give it a try how state can look like now in the process. And yeah, let's just start the table service and see what's going on. Hmm?
The application properties file has a typo.
Ooh. Rename application proper. Oh, perfect. I love live coding. It's more like collaborative coding. So it's. The starter. Yeah, that's true as well. Good that you are here. And the worker has the add component. Okay, now we should be good to go. And also good to see that you pay attention. Yeah, that's really nice. Oh no. That's again. Yeah, so I have to, actually I cannot deploy this thing without defining those things. It's a problem here also with the process. I will just quickly add those things, but we have not implemented them, doesn't matter. I forgot that, but we have here the type that needs to be here, so and then the message also needs to have some name, so that it exists within the system, so we can call it message. Let's say this is food. I also call it food. And this one here becomes message drinks. And actually also I need to define a correlation key so that I know how to correlate the message or what should correlate the message. And this is the order ID. And then I save this. And now I think we are ready to go. Exciting times. Oh, did I not do that? Not, apparently not. So now it's here. Are we still having the right model? Let's see. That looks good. This looks promising. Oh, not terminal, but run. Okay, cool. Let's give it a try. Let's order something. I mean, we will not receive the order here because we are not. Oh well, maybe we will. Let's see. I mean, we call the right things, and we still have the consumer, so we haven't changed the logic. So probably we will receive it. Yeah, we still receive it because we haven't changed the logic. But let's look. We haven't changed the code logic, but let's look what happens in the process model, just for what I mean when I talk about overview. And I'm here in the Camunda console. And I have a tool here called Operate. So here I can observe here what's going on in my table process. And actually, yeah, so what has happened so far, it's what we did, right? We deployed the process model to the workflow engine. We created one worker that handled the order. And actually, this handle order did something. It produced 2 messages to Kafka. And in our table service, we still consume the messages from Kafka and send them right directly back to the terminal. So that's why we are still waiting here for the messages to arrive. So maybe let's give that a change and go to the ZB controller and have one last thing for the message. Oh. Writing is today not my thing. Send message. And again, I'm using the ZB. No, I auto-wire. I'm not using the worker, but I'm auto-wire the ZB client here. Okay. Don't forget the component this time. And what I'm doing is publish a new message. I have the message name. The correlation key. And then I can also basically send. And join. So what we need here is we need the message name and we need the correlation key. Okay. Good thing. And then we have the correlation key. So what I can do now basically is I said that we haven't changed that, and exactly it's happening basically here. We are still getting the message food is ready, but we send directly to Kafka also deliver the food. But from the logic of the state, we want to change that. So what we do here is we comment this out. And basically we'll use we'll auto-wire here as well the wrong written message. And then it's here where we can basically say message, send message, and I need to provide the message name, and I have to find it in the model again. So that's how I can attach the things again. And I also need the correlation key, so I take the order ID here, and then that should do the trick, and let's copy and paste the same for. And this was the message. Wait. This message drinks, I think. And also the order ID. That should do the trick. No, I'm missing something. Yeah, perfect. And then I'm now sending the message, so the process is aware. And one more thing I need to do here, I need to make the worker as well for the at ZB components. So afterwards we can have also a worker for handle order, but we have here 2 more workers that we want to make aware of this deliver food. So I go here for this type, deliver food, and then I'm not sending the food order anymore, but I'm sending the message send, not food, send just the food, and have here the order ID. Handle food, and here we do handle drinks. Also here I'm just sending the drinks this time, not the drink order but the ready drinks. I think this is send drinks. Perfect. Also using the order ID. Perfect, that looks good. Where do you see that? I'm not. Here. Yeah. For the type, or are you seeing something else that I'm not seeing? It's late. So I have deliver food and deliver drinks. So. Train 88. But that's okay, actually, because I want to send now food to Kafka. So what I want... Maybe it's... the order... Oh, sorry, yeah, I didn't... Send food. Yeah, you're right. Sorry. I should name my components better next time to not confuse myself. Yeah. Perfect. This looks fine. Let's start this thing up and hope nothing breaks. Why would it? And let's see if it still is working. Yeah, so I'm still getting the things. Let's look how we have the view in Operate. So in the tool where we can observe the state, actually, and we see... oh, that is a different one. Sorry. Let's go to the processes we have, or to the dashboard. So we are in the table process. And we have a completed instance, hopefully. And that's actually not the running instance where we still wait for the message, but that's the one that I just triggered, so we go through. Cool. There are 5 minutes left. I really would like to show you what that means to be proactive now. So now we have state in the table service, but now we can do really cool things with it, actually. So now we can go and change, change a little bit also the business logic, the Saga logic. So maybe we are a restaurant that serves food and drinks at the same time. Who knows? Maybe we do that. Probably not the most economical reason. But what I can do now quite easily is I could say, OK, the workflow engine takes care that both messages are arriving. And just if both messages are arriving, I'm going to this, to this service task, deliver food. I'm not changing the logic right now, but I changed the process. So what I can do now is I can just stop the application and deploy it. And I already stopped it, but I can deploy it. And I have deployed a new logic here. And I can say, well, I haven't changed it, but I should say order 6. And I will just receive here the food because I haven't attached it to this worker, but that's fine. But what I want to show you is now if I go to Operate, again, I have a second version here, hopefully. Did I? Oh, yeah. That is... Why is this happening? Yeah, probably. Yeah, you're right. OK, cool. Let's just do it again. That should work now. So I'm getting here the food service is still producing the message. And if I look now into Operate, so now I should have this view. Let's refresh. From the table process, I have here the second version. The nice thing is it stepped through, so we miss a message going to Kafka for delivered drinks, but that's fine. We also see that the workflow engine can take care of versioning for us. So that means if we change our pattern, our business logic, the workflow can, or the engine takes care of that. And all the other instances, because we still have 2 messages waiting here at version 1, they will stick to the old version where they have been started, and that's super handy. We can also add multiple things here and make it a little bit more complex, just like to outline this. What I can do is I can add an event sub-process. So I can be really proactive about my time. So I can start and saying as soon as this process starts, the workflow engine also gives me an indication about the time. And maybe if my customer has to wait for 20 minutes, I want to give a discount. So that is things that I can define within the Saga pattern. And normally, if we have to code a timer, we all know that this is kind of not really nice and not as, normally is not as nice as to have it here visually or like having it taken care of a workflow engine. So I could then just basically say, give discount to customer. And I'm not going to deploy this now, but you probably get the idea and take the time to sum up. Because we've seen some stuff, you helped me, which is great. So that was a demo. I used ZB. We also could think of, we just had one service having ZB. We could also think that we have the workflow engine across multiple services. So we could think of more a microservice orchestration part here. What you choose or how you choose that depends really how it makes sense to your architecture and how it fits. So for some people, that is a good pattern, and for others, they really like to have the state within one service. If you want to play around with this, there's a really cool book about practical process automation I can recommend. It's super nice written, and yeah, I read it really quickly, which is normally not the case if you read like a what's that called? Not like a fiction book, but you know what I mean, a non-fiction book. And there is a GitHub repo, Flowing Retail, with multiple examples how you can use actually workflow engines in different environments, which is also super nice to check out. So let's recap. We went from an application today, or we talked about different components. We went from an architecture with just blocking calls to something more reactive, or we introduced reactive coding, and then we went to events. And we used Kafka as a message broker. And in order to be aware what's happening in the systems, we introduced a workflow engine to manage the state. And it's not about just choosing one of them. It depends, and I guess you heard that a lot. It depends what you need and what your architecture looks like. And probably you need to use multiple of those methods to implement your overall system. And I hope what you take away is that workflow engine is a really cool element to add to your toolbox when it comes to state. Thank you so much.